we got another example. The very first thing which I would do, I would simply redraw this circuit. Now, this is my point A. This is my point B. So my voltage source, okay, the positive terminal is connected to point A. This is my point A. Okay, and my negative terminal is connected to point B. Point A is connected with resistor R2, okay, and R2 is connected with resistor R1 is connected to point B. So I'm going to draw point A, this is the positive terminal, the longer one is the positive, goes to resistor R2, and R2 is connected to R1, excuse me. Okay, so this is my R1. Next, we're supposed to connect point A with resistor R3. So I have R3 over here, and I have R3 in series with R4, and R4 goes to point B. Okay, so this is my circuit, and my point VA is over here. Okay, this is my VA is at resistor R2, this is my VA. And my VB is between resistor R3 and resistor R4, this is my VB. Okay, we're supposed to find the current which goes through resistor R3. So you can say I3. This is my voltage source, 5 volts, and I'm supposed to also find the current which goes through resistor R2. I have to find I2. So now the circuit looks a little bit simpler. So what I'm going to do, first I'm going to find the equivalent resistances for these two resistors and these two resistors. So R1, 2 is equal R1 plus R2 because these two resistors are in series. So R1 is equal 3 kilo ohms plus R2, which is equal 5 kilo ohms. This is equal 8 kilo ohms. Next, I'm supposed to find R34. R34 is R3 plus R4. R3 is equal 4 kilo ohms plus R4, which is equal 2 kilo ohms, is equal 6 kilo ohms. So now we can redraw the circuit, and my circuit is going to look like this. This is my R1, 2, and this is my R3, 4. Now you're supposed to realize that the voltage source is connected across each of these two resistors. So the voltage across resistor R1, 2 is equal voltage source, and voltage across resistor 3, 4 is also equal to voltage source. So let me write this down. This is my KVL, and this is looks like this. This is voltage source is equal V R1, 2, and this is also equal to V R3, 4. Okay, and this is equal 5 volts. Now I can find the currents which go through these two resistors. Okay, if I will find the current which goes through this resistor, it means that this is the same current which will go through these two resistors. So I can say that I1 is equal to I2, and this is equal to I1 1, 2, and we will calculate it by simply dividing voltage source over R12. Voltage source is equal 5 volts divided by R12, which is equal 8 kilo ohms. This is equal 5 divided by 8 exponent 3 equals 625 microamps. 625 microamps. Next, I can find the current I3, which is equal I4, and this is equal I34. This is voltage source over R34. Voltage source is equal 5 volts over 6 kilo ohms. This is equal 5 divided by 6 exponent 3 equals 800 is equal 833.33 micro. 833.33 microamps. Okay, so I found this current. This is my I3, and I found this current, which is equal my I2. Now we're supposed to find the voltage VA. Voltage VA is the voltage between this point and ground. Please notice that VA, this point, is connected to the positive terminal of my voltage source. So VA is the voltage between this point and ground. Okay, so this is nothing else, just my voltage source. So VA is equal voltage source, and this is equal 5 volts. One more time, because VA is connected directly to the positive terminal of my power supply. That's why I'm going to measure between these 2 points the value of my voltage source. Next, I'm supposed to find VB. VB is nothing else, just the voltage across resistor R4, because voltage VB is measured between this point and ground. In other words, we can also put ground over here. So because this is just ground, so voltage across resistor R4 is my VB. I'm going to use the voltage divider formula to find that voltage. So VB is equal voltage source times R4 over R3 plus R4. You have to practice these formulas. Okay, that's why I keep changing them all the time, just to make you think. Voltage source is equal 5 volts times R4 is equal 2 kilo ohms over R3 4 kilo ohms plus R4, which is equal 2 kilo ohms. Close parenthesis, this is equal 5 times 2 exponent 3 divided by 4 exponent 3 plus 2 exponent 3. Close parenthesis, this is equal 1.67 volts. Okay, so this is voltage at point B. Okay, this is the voltage at this point. Next, we can find VAB. VAB is simply the difference between these two voltages. So I have 5 volts minus, let me write the formula maybe first. So I'm supposed to write this is VA minus VB, where VA is equal 5 volts minus 1.67 volts. Okay, and this is equal 3.33 volts, but let me check on the calculator. This is 5 minus 1.67. This is equal 3.33 volts. 3.33 volts. This is the voltage between these 2 points, VAB. Next, we're supposed to find the power at resistor R2, and we're supposed to also find the power at resistor R3. So P2 is equal I2 squared times R2. I2 is equal 625 microamps to the second power times R2, which is equal 5 kilo ohms. So this is equal 625 exponent 6 negative to the second power times 5 exponent 3 equals 1.95 milliwatts. 1.95 milliwatts. And P3 is equal I3 to the second power times R3. This is equal 833.33 microamps to the second power, this, times R3, and R3 is equal 4 kilo ohms, and this is equal 833.33 exponent 6 negative to the second power times 4 exponent 3. This is equal 2.77 milliwatts. 2.77 milliwatts. We found the powers, we found the voltages, we found the currents. So now we can say that this problem is solved.